Okay, we're going to talk about the order of initialization a little bit. It's a really big topic. This is one of the ones where it is different in different languages. So Java is going to work different than C++, different than C# potentially. This is something you need to be aware of with language, but you need to learn it for that specific language. I will show you the basics of it for Java, plus a little, some things that you may not find elsewhere. And it'll be things you commonly see me do in class or in the course. We'll make another class. Parent class, and we'll make the child class too. No, that's a mistake. So we're gonna get into a bit more realistic. Now we have multiple files. No, actually we'll keep that as a non-abstract. Multiple files for each class, so we can't see everything all on one screen, and there'll be some jumping around, which is the kind of thing you'll need to get used to. So let's keep it simple here. Here's a question for you. You can pause while you think of the answer. What is the static type of value, and what is the dynamic type of value? Okay, pause and let's see. So in this case, they're both parent. If I change this to child, what's the static and what's the dynamic version or value for, or which one's static, which one's dynamic for value? Pause. So parent is the static one and child is the dynamic one. I'm going to ask one more question, more of a theoretical question. Where do we use the static and where do we use the dynamic? So pause. So the static one gets used by the compiler to see if things are legal, right? So does child extend from parent? Does, is there a foo method on parent or higher? There isn't, so it's an error. The dynamic one is, what does the runtime do? So when we call foo, what's it going to call it on? It's going to call it on child. Right? So remember those things. So for now, we're going to stick with everything as parent. And we're not going to call any methods or anything. We'll just run this to start and see that it's very boring. It didn't do anything. We will go into parent. Remember, this is exactly the default constructor. It takes no arguments, and all it does is call super. Run it again, and it will be boring. This doesn't compile. Why not? So the answer is super must be the first thing in the constructor. Has to be. You don't have a choice. There we go. And super is totally optional. If you're just calling super with no arguments, you can just let the compiler put it in for you. So now we see parent. If we go into child and do the same kind of thing, now remember, there's a call to super here. We didn't put it in. The compiler did it for us. That means it's going to go to parent and call the constructor there that takes no arguments, which will then go to object, because so this one extends from, and it will call it to the one that takes no arguments. So if we change this to child now, we will see that it prints out parent and that it prints out child, which is exactly what we expected, because we came into child it called super, which went to parent, it called super, which went to object, came back, did parent, did child. So most languages work this way. Swift, if I remember correctly, works a little bit different, but I think you do super at the end. I'm trying to remember off the top of my head. I don't. But generally speaking, they all work roughly this way. Where Java is different, or maybe different from some other languages, is they have this concept here. Which is called an instance initialization block. So let's see where this gets called. And we'll put it in child as well. So do child.init, and we'll do parent.init. So notice that the parent init gets called, and then the parent, and the child init gets called, and then the child. So essentially, and this is kind of lying, kind of telling you the truth. It won't look like this, but this really becomes a method like that. So this is the way things work. So I just commented out because it's not, I guess, well, public void. So you put it in like that. The compiler generates the things with the dollar signs. Okay? So this doesn't actually have a name, but you can't just have code without a name in Java. It ultimately has to have a name. So the compiler actually generates a hidden method for you, and it then inserts the call right after super. And if we had two blocks, it would just do them in the order that they appear. It also wouldn't matter where they appear in the file. It's just literally the order that these blocks appear. And we don't actually give them methods, and we don't actually call them, but that's what the compiler does. So it doesn't matter the order. I always put them at the top of the file. Actually, not quite. Usually I put my variables up first, but I'll put these instance initializers right above the constructors. Should I put a 1 there? Right, so we see it calls 1 and 2. Where would we use this? We use this, I use this for anything that I'm going to initialize. So let's say this has X. Right, so here I can't, I want to make sure that that X gets the value that was passed in. But let's say I also have another variable here. Get rid of this, don't need it. We'll get rid of the system print line. Let's say Y is always going to be 11 no matter what. It was going to start off as 11 no matter what. I don't need to put that inside of the constructor here because it doesn't depend on any of the parameters. So the way I do things in general is that the constructor gets does all the setting of things based on the parameters, and anything that can be initialized without parameters gets done here. So that's one of that's the main reason I use this kind of thing. In addition, I'm just going to get rid of this. We don't need it right now. I do want to have that instance block though. There's another thing. You've seen stuff like this. So this is how we make a constant, right? And a constant, you give it a value like that. Most of the time I don't do that. I make a static block and I assign it there. Now final means that it can only be given a value once. So if I try and do x is assigned 11, it won't work. If I try and do it out here, it won't work, right? So static is shared amongst all the classes, or all the instances of the class. It actually exists even without an instance. So when we go to when we use this class for the first time, the virtual machine has to go out and find it and do what we call loading it. When the class gets loaded, this static stuff happens as well. So I use this for a similar thing. I use this to set up all of my constants or shared things. Now, why can't I just set up my constants like a normal person? And I declare the constant, and it's got the value here. This is what's called a blank final. It doesn't have a value yet, and we can do things like this. So if some condition is true, we can make x equal 10. Otherwise, if that condition was false, we can make x equal 11. It's still final. It'll have the value of either 10 or 11, but we don't know which. It depends on what this is. The other reason I use it is to load things from a file. So say I want to when the program starts up, I want to read something from a file when this class gets used and set my constants that way. That way I can change the value of my constants without having to recompile the code, which can be quite useful sometimes. I only want to have that happen once. Well, the static thing is what happens once. So that is the way you can achieve that. So we've done this in the parent. I'm just going to comment this out for now so we don't have too much noise. And I'm going to go to the main. I'm going to make this a parent. Let's run it. And what we see is just a extra spacer, threw me for a loop. So we have the static that happens before the call to new. Right. So let's print out here A, B. What I want to know is, did it call it the static block here when I declared the variable, or did I call it here when I said new? And it called it when we said new. And if I call new again, we see the constructor got executed twice, but the static block only got initialized once. And if we come in here and uncomment this, we'll see that the same thing happens with the instance block. It gets called once per constructor. Once per constructor, but the static only happens one time. The child, if we did static as well, and it's the same thing. You can have multiple occurrences of static, and they can appear in any order in the file. It just executes them from top to bottom. So this one's going to be a little bit different. We're going to cause the parent to get loaded, which means it's going to do the static block for the parent, then it's going to do the initialization and the constructor. And then when we do the child, it's going to go, I've already done the static block for the parent, so I don't do that again. But I haven't done the static block for the child yet, so I'll do that, and then continue on with the constructors. So there's the static for the parent, the constructor stuff for the parent, the static for the child, didn't redo the parent stuff, and this constructor for the parent, the constructor for the child. Simple set of rules. That is it. So we really have just a few things we can do with constructors. We can call super, or we can call this. Super calls the one in the parent class. This calls the one in our own class. Ultimately, something's got to call the one in the parent. And then we have the instance initialization block, which gets run after the call to super, but before the body of the constructor. And we have the static block, which gets done when the class gets loaded, which is the first time we actually go to use the class, not just declare a variable of the class, not just pass in a parameter, but actually use that value. So we have to ultimately say new on it, or call a static method, or reference a static variable of it. So something that would actually mean that the class is going to be used. Here it's just some information. It's just a variable declaration. It doesn't tell us anything. If you can remember that stuff for the order of initialization, that will be useful. You will see me use all of this stuff in my codes, and the assignments generally make it easier if you remember things like this. So do come back and watch this video, which is why I'm trying to keep them nice and short and sweet.